started the event about, but just to give a brief introduction, we're going to do a talk from four speakers today, two from blockchain industry, one from cannabis industry, and one from Electronic Frontier Foundation. So the theme is enterprise adoption for cryptocurrency. So the tech companies will talk about what their efforts are with tech and cryptocurrency. And this company talking about the practical side and how they, in the use case of blockchain, how they can utilize it. And we also have EFF here talking about their efforts on policy and regulation around cryptocurrency, financial censorship, etc. So yeah, thanks everyone for coming. Our first talk is from QuarkChain. So we have Dr.Zhou, QuarkChain CEO, who will be discussing about the topic. So please give him a big round of applause.
Great. Thanks, everybody here. My name is Dr.Zhou. I'm the founder of QuarkChain. A little bit of myself. Before I established QuarkChain, I worked at Google and Facebook in their infrastructure team, and I work in their high-performance systems, distributed systems. So when I see blockchain, I say, oh, this looks like it's in early stage of what centralized system has done. So I believe there's a lot of this 10 decades of experience can be applied to this area. And so what is QuarkChain? Actually, QuarkChain is we aim to build the next generation blockchain by using multi-chain or sharding technologies, where sharding actually is the core technology that used in both Google and Facebook and basically any internet companies in order to support their billion users services and scale their infrastructure. Okay, and so today I will discuss how, from our viewpoint, suppose after 1 or 2 years or 5 years or maybe even 10 years, how the future blockchain will looks like, and especially with such kind of the blockchain infrastructures, what kind of business it can be empowered. Okay, so let's start. So actually, recently these days we have seen a lot of top organizations entering into the blockchain business, and we know that since the debut of Bitcoin, blockchain actually brings a lot of benefits: transparency, distributed governance, and also traceability, and trustless third party. And a lot of this actually attracting a lot of, for example, financial services and financial sectors that are looking in this area. And for example, Facebook actually last year, in the middle of last year, they announced their project called Facebook Libra. And this Libra is basically using blockchain technology and using most likely US dollar as a back cryptocurrency, and then provide globalized borderless financial service around the world, especially targeting for those people, billions of users, that they are hard to access their local financial service, such as bank, and such as lack of documents. But it allows them to, but they have the internet access, so they're able to access the Libra service directly without going through traditional banking services. And this also motivates a lot of, actually, what is called central bank digital currency. Actually, this is over here, central bank digital currency, to provide their solutions. For example, in China last year, in October 24th, President Xi announced that blockchain will be a statewide strategy and to encourage blockchain to core technology development, and also together to encourage this blockchain to apply to the commercial business. And so, with a lot of this movement in blockchains, we saw there are several big trends in this area. So, for example, in China, it's probably difficult to, for example, advertise for public blockchain because cryptocurrency is directly compete with, for example, central bank currency. But it greatly encouraged, for example, the research of consortium. And we also see that a lot of blockchains, they are also public blockchains. They are also combining some features of consortium. So, for example, for Facebook Libra, aims to build a public blockchain to use for billions of users. But actually, it starts with a permission consortium mode so that it will invite 100 memberships to join together in order it is able to achieve desired performance. And second is that using kind of cryptocurrency that is, for example, using generated by local consensus, it uses some kind of the fiat-backed cryptocurrency, which from regulation perspective, that is more widely accepted. And so we see that there's a trend that people try to utilize both public blockchain and consortium blockchain and build a middle ground so that they can harvest from the both benefits of those two technologies. And as a result, we are expecting in the future they should have a solution that is able to harvest the both benefits. It's able to provide, for example, a kind of permission list in the same network so that those people are able to freely to join the network, while in order to satisfy some regulations, part of this network can be consortium. It has permission member, it has some highly regulated cryptocurrency, but this exchange of these two networks can be smoothly handled by kind of network consensus. And second evolution, actually, we have seen there's also a lot of great trend is moving towards is to try to address a lot of public blockchain challenges. So we know a lot of famous projects like, for example, Ethereum 2.0, Polkadot, and Cosmos. They are actually addressing one or two or three of these problems in order to make sure that public blockchain can be more secure, can have more people to come to join, and is able to, for example, to upgrade the network without, for example, making a fork, and be able to scale, for example, thousands or even tens of thousands of transactions. And lastly is that it can incorporate hybrid token economies so that it can, for example, for payment, a lot of commercial scenarios, it can use some stablecoin. And while for other cases, for asset-wise, it can still also using native tokens such as Ether, Bitcoin. And so after actually seeing these two trends, we believe that the future blockchain should have all these properties. First, it should have very high transaction per second. So for example, we just do a simple calculation of there are about more than 2 billion users on Facebook. And suppose each user submit one transaction to a network per day, then the required transaction per second will be more than 20,000 transactions. While a lot of existing blockchain, even Facebook Libra itself, which claims to achieve 1,000 transactions, is still far away from the number I just described. So we need kind of blockchain to be able to achieve high transaction per second, while with some seconds latency, so that people can just don't have to wait for half hours, for example, in the Bitcoin network, to make sure the Bitcoin transfer is being finalized. Or if people want to perform DeFi, they probably don't need to wait for maybe several minutes until the loan or some corresponding DeFi features has been done. In addition, besides transaction, there's also another feature that I think is very important. While in a lot of cases people ignore at the moment is the capacity, storage capacity, because when we have billions of users, they're using the network. then we were expecting that the storage growth will also grow dramatically, and it should be able to handle not just several hundreds of megabytes like Bitcoin or several hundreds of gigabytes like Ethereum, but it should be able to process, for example, terabytes of data. And actually, we already achieved that in our centralized system using big data technologies. Another direction that I think future blockchain should have is that it can allow a lot of users to join the network and especially be able to contribute to the network. So for example, right now, for proof of work-based network like Bitcoin or Ethereum, suppose a miner wants to be a solo mining by owning 1 to the 1,000 hash power of the network. In general, require millions of dollars of the cost to buy those devices in order to have this hash power. Or if suppose I have less than this hash power, then I need to rely on mining pools, which means that it encourages centralization and sometimes will cause the security concerns of the network. So we need a way to be able to allow those, for example, hash power providers with lower cost still able to join the network and contribute to it. And besides that, actually, the token holder is also one of the also important members of the community. And their contribution to the network should also be counted towards the, for example, network security and also the progress of the network. And third is the security. Definitely, as more and more assets are running on top of blockchain, we need a very guaranteed security to make sure these assets will not be, for example, be lost, be spent, or sometimes, for example, be artificially created. And actually, we see a lot of technology are moving towards that direction. For example, Facebook Libra, they propose a language called Move that is able to, for example, to secure all the resources to prevent them from being creating, copying, or destroyed. And this is something that we really believe that will be more popular in this blockchain world. And besides, for example, language support, better language, there's also, we believe there's an also stronger consensus to make sure that attacking the network will be much costly compared to existing protocols such as proof of work or proof of stake. And flexibility means that we are able to dynamically upgrade the network in order to satisfy different needs in terms of scalability, in terms of new, for example, virtual machines like Move, or in terms of new like token economies, like for example, we can have different kinds of the native stablecoin. So we also need kind of this flexibility to be able to do that. So one example we see is like Polkadot is now implement kind called upgradable routine, so that it can reach kind of on-chain consensus to upgrade its network directly without making a fork. And we believe this is also a very important direction of blockchain to be, I would say, self-evolved without say, hey, we make those for example, voters make maybe a conference and say, oh, we decide we should go to this direction or that direction. All the things, all the evolution are on-chain and immutable. And it can support a lot of native assets. Here, I emphasize on native is that all these assets, they are actually in a lot of network. Originally, Bitcoin has only one asset, that's Bitcoin. Now we have Ethereum with multiple assets. But actually, Ethereum compared to others, Ethereum is first class, while others are second class, which means that those second class assets may not have the same functionality as the first class, and also is more vulnerable. For example, we see a lot of ERC20 security issue. For example, overflowing, so that people can create arbitrary ERC20 tokens. That happened before. And people cannot using, for example, USDT to pay transaction fees. and have to calculate this fee using Ether when submitting transactions. And so actually, we need a lot of these native assets, and all those native assets be able to, for example, to satisfy different commercial needs without saying, hey, without worry about security issue, without worry about it's not being able to, for example, to artificially being created. And lastly, is that with the rise also of the consortium blockchain, we also need kind of bridge technologies so that this public blockchain and consortium blockchain can some sense can talk with each other. So that, for example, now have a consortium asset. This asset with some cryptographic proof, we can move it from consortium to public, or from public to consortium. And this will also be encourage a lot of kind of like, for example, public and consortium business. Okay. Any questions? So now I move to the next part, is that how we are able to contribute these future blockchains, and I will tell you some early applications that we already signed with our commercial partners. So first of all, we are building a family, I would say a family of products in order to satisfy these different needs of blockchain, empowered by our sharding consensus or boson consensus. So first of all, what is the boson consensus? Actually, the consensus relationship with our blockchain is kind of a Bitcoin with actually blockchain with Bitcoin. So it's a generalized multi-chain consensus with, I think, three key properties. So the first property is that it provides shared security to all the assets in the network, or all the chains in the network, so that people don't worry about, as long as this root chain has sufficient hash power, has sufficiently validators, then all the assets on the network is secure. And second is that it allows supporting multiple consensus, multiple chains, before shard chains running in the same network. They are heterogeneous, which means that they can run different consensus ledger model, or even token economies. Suppose that one is running like Ether-like chain, while another is running on Libra-like chain, and they can run in parallel. And the third major important is that these two chains actually can talk with each other. I can move a ERC20 asset by using our QuarkChain protocol to move to Libra. Now it can be our Libra resources. We can also move these Libra resources from Libra chain to Ethereum chain, so they can become the corresponding ERC20, as long as they have defined such kind of protocol in the root chain. And so this allows us to have a single consensus, generalized consensus, but apply to different applications, scenarios. So one is first is public blockchain. So that's why we built QuarkChain, which is able to target to next generation public blockchain with enhanced single chain consensus, which we call proof of stake work, by combining the benefit of staking and proof of work. And you can achieve very high performance, which our community members report that we have 300,000 transactions per second. And we provide two versions of the QuarkChain in terms of Python and Go QuarkChain, so that we will not suffer from single implementation failure, which to my knowledge, right now only Ethereum has such kind of a robustness. And second is that we also developed QuarkChain Union, which is a consortium blockchain platform. By adding a lot of consortium features in terms of consensus, we can support RAT, that is a crash fault tolerance consensus, and standard BFT consensus. We also provide multi-level access control, so that we can control who can join the network, or who is able to produce the block in each chain. And also, yeah, it is able to bridge to other blockchains, such as the famous IBM Hyperledger Fabric. And the lastly is the one actual experiment project we are currently working on is sharding Libra, which basically the goal is to scale Facebook Libra by 100x performance, and also we encourage more decentralization and optimize the move language so that it can support secure and scalable interoperability. And so here is a general comparison of what we have with other famous projects like Stanford, and Cosmos. So I would like to highlight maybe 2 facts. One is that our network is already launched. It's running live in more than half year. It's already supported by multiple exchanges. All the assets are running smoothly, including cross-chain interoperability. While all this, from my understanding, these are 2 crypto are still testing. And Cosmos actually is only support a single chain, and the corresponding IBC, inter-blockchain communication, is still under testing or under design. And second is that we can support heterogeneous chains and all the chains share the same security as I mentioned before. As a summary, this is what we can achieve right now. We have complete solutions for different types of blockchain, public, consortium, support model consensus, BFT, POSW, and we are allowed more participants to join the network. And we have our community members to demonstrate the 300,000 transaction, and also have the flexibility to, for example, employ different ledger model and also transaction model. And they also allow the, for example, public consortium blockchain bridge so that both of them can, for example, communicate with each other. Many thanks for attending my presentation. So we are happy to answer any questions, and also we have several all our code here are open source, so you can find it from our GitHub. And also free to take a look at our website, and there's some more discussion on how our technology to achieve all those goals. So thank you, everyone.
We'll do Q&A session after, about networking time.
Okay,
yeah.
Sure.
Thank you. Please give another hand of applause to CEO. So next up, I'll be speaking briefly about SpareX and our efforts on enterprise adoption.